Have you ever sat in a massive sports bar, looked up at those dozens of perfectly synced screens and just wondered how they actually pull that off without the entire system crashing?
Right. It's crazy to think about.
It really is. Welcome to the Deep Dive. Our mission today is to explore the massive hidden infrastructure behind commercial audiovisual setups. We're pulling back the curtain using the product catalog of HDTV Supply. They're a company with, 25 years of experience in the global AV space.
Yeah, and it's exactly the kind of engineering you never really notice until it goes wrong.
Oh, absolutely.
I mean, we just sit there and expect the picture to be perfectly clear and happening in real time, right? But the physical reality making that happen behind the drywall is just wild.
And it all starts right at the foundational level. Looking through the source catalog, there's a specific product that caught my eye. It's the DVIGear DVI-2507-AOC HDMI cable.
Oh yeah, the hyperlight ones.
Yeah. It's a 7.5 meter, so about a 24.5-foot active optical cable. But, okay, let's unpack this. Why go through the trouble of using optical fiber for a relatively short 24-foot run? I mean, a standard copper HDMI cable seems to work totally fine in my living room.
Well, it works in a living room, sure. But in high-stakes AV environments, you're pushing uncompressed 4K video, audio, and control signals all simultaneously.
Right.
Traditional copper cables send electrical signals, so that makes them highly susceptible to electrical resistance and electromagnetic interference. Think of copper like shouting a message down a long, noisy hallway.
Oh, okay.
The further that shout travels, the more degraded and garbled it gets by outside noise. So at 24 feet with 4K data, you start risking latency or pixelation.
So if copper is like shutting down a congested hallway, fiber optic is something else entirely.
Right.
Like a frictionless bullet train?
Yeah, exactly. What's fascinating here is that fiber optic uses pulses of light bouncing inside a mirrored glass tube. It traps the signal completely, making it immune to outside noise. But the really crucial detail here is that this is an active optical cable.
Active meaning, what, it has its own power?
Sort of. The active part means there are microscopic computer chips built right into the connectors themselves.
Wait, really? Like inside the tiny plug?
Yeah, right in the plug. They instantly convert the electrical signal from your device into light, shoot it down the fiber at 186,000 miles per second, and convert it back to electricity at the screen. Zero signal degradation.
Wow. That makes complete sense for keeping the signal pristine. But a flawless fiber optic signal doesn't really help if it doesn't know where to go.
Right, you need a router.
Exactly. When you have dozens of screens, how does a specific video feed know which cable to travel down? That requires a massive central brain, which brings us to the Wolfpack modular matrix switchers. The catalog shows these systems scaling all the way up to 160 by 160 HDMI matrix switches over a local area network.
It's just a staggering amount of processing power.
But 160 screens is completely insane. I mean, are Vegas sports bars really the only people with the budget or need for a massive 160 screen matrix?
You'd think so, but if you look at HDTV Supply's procurement data, a massive chunk of this hardware is actually going to the federal government.
The government? Wait, why?
Yeah, they list all these specialized federal purchasing categories in the catalog. Things like GSA schedules, TAA-approved products, and they even utilize the NASA SUPP program.
Okay, I know NASA, obviously, but those other acronyms just sound like bureaucratic red tape. What do they actually mean for AV equipment?
Essentially, they're just strict federal contracts that verify the equipment is secure, reliable, and manufactured in approved countries so government agencies can buy it safely.
Gotcha.
A matrix switcher is fundamentally just a massive digital traffic cop. It mathematically routes any video input to any output monitor instantly. So the underlying hardware requirements are identical, whether you're trying to route Sunday football to a wall of TVs or power an emergency response grid and a space launch mission control room.
Okay, but if you've got a central matrix brain routing high-fidelity data to 160 different monitors, the logistics of controlling that seem like a total nightmare. I'm picturing a giant switchboard with 1,000 physical dials.
Well, the heavy lifting is entirely handled inside that matrix box. The source catalog actually outlines incredibly streamlined control options.
Like what?
You can use dedicated Wolfpad TV control tablets, standard Windows 11 software, or even a web GUI, which just means you log in and control it through a standard web browser. There are even free iOS and Android apps, plus integrated DirecTV apps.
So you're telling me a system robust enough to run a NASA command center can literally be controlled by someone swiping on a free smartphone app. It's like steering a nuclear submarine with an iPad.
It really is. But it highlights a core philosophy of modern AV design. The complexity has to remain completely hidden.
Right. The user just wants it to work.
Exactly. An emergency responder or a bartender just needs to drag and drop a video feed onto a screen icon and trust the system handles the millions of calculations required to make it appear.
So the next time you're sitting in a massive sports bar looking at a giant, perfectly synced video wall, you'll know exactly what's powering it behind the scenes.
Right, it's definitely not magic.
No, it's miles of glass fiber acting as a perfect light tunnel, feeding into a massive digital traffic cop, all wrangled by a simple tap on a touchscreen.
But that massive infrastructure is about to face a serious stress test, actually, because the catalog already features an entire section dedicated to 8K HDMI products.
Right, and the bandwidth doesn't just double from 4K to 8K, it completely quadruples.
Exactly. If a 160-screen 4K matrix requires this much active optical fiber and processing power today, what happens to our physical infrastructure when every single one of those screens inevitably demands 8K data rates?
Oh, well, yeah, how much deeper will the fiber need to run to keep that picture perfect? That's definitely something to think about.